Okay, in this problem, which we were using as a do now, I found out that people are not really understanding when you get those numbers for doing an equilibrium constant problem, where you're figuring out the K equilibrium, then, well, this is, of course, the expression. It's not the value of K equilibrium. So what we're doing is we're trying to figure out how to make this work, because in this problem, if you look on the page for this problem, where is it? I don't have it here. So as we look on page 592, number 71, this is what I wrote down as the given and find. Okay, you don't have to manipulate the numbers for where they are in the expression on this particular problem, which is nice. So what are we going to have to do, though? Since these are moles and not molarity, and one more time, molarity is not moles. They are not the same. The big letter M stands for moles over liters. Fortunately, they kept the numbers fairly simple, which is a real blessing. So, number 71, we've got a volume of 6 liters. Ah, that solves our problem. That really solves our problem. I mean, it takes care of the problem of not having molarities, because moles over liters, all these guys are in the same container. So what are we going to do? We're going to take this guy and we're going to divide him by 6. Someone run me a number, please, so we know what this number is, so we can put it here into the video. Okay, so when you divide this out, now you have molarity. And now this is the number that we're going to be putting into, see, here's moles over liters again. That makes concentration. And so when we do our K equilibrium expression, which, what is on the top, products or reactants? You want to revise that? Okay, I'm hearing reactants from the students. What's on the right side of the equation? Products. Okay. You remember when I was hoping you might remember that if you go left to right in an equation, normal thing to happen with reactants is they go to the right. But of course, equilibrium, they go both ways. But if you think of the normal case where we go right, and then you start at the bottom with what's on the left, the PCl5, you see he's on the bottom. So reactants are on the bottom. And on the top, we have the PCl3 and the Cl2. So now what we're going to do is we're going to divide each one of these by 6, and then we'll use that number that we get from there. And by the way, is there a 0 after this 37? There's no zeros after the 37? That's good, because what that means is we have another sig fig. So I'm going to add a 0 there. So we actually have 3 sig figs. Remember, your calculator doesn't understand sig figs. Okay? I don't know of any calculators that know about sig figs. So at any rate, we'll make this a 3 sig fig number. Now, this guy is 4 sig figs, but because the other two are only 3 sig figs, we'll have 3 sig figs in our answer and no more. Okay. So brackets mean concentration. So we're putting the concentrations in these brackets into the expression. And that is the balanced equation. Okay, no coefficients, so we don't have any exponents up here. Okay? Now it's just a matter of plugging in the numbers and you get K sub EQ, the equilibrium expression. In today's announcements, I wanted to add this to the video. You want to stop the video and read this so that you can be well apprised of what's going on. And so stop the video now and take a look at this screen. Next, I'm going to show you where to find my videos, and if they work, fine. If they don't, I've uploaded them to my other site, SmugMug, as well as to YouTube. So if you go to this week's Monday, you'll find a video there. I don't have any problem opening it, but I had a couple of students earlier today that had some big problems getting this to work. So, you know, when you go there, hopefully it will work like this for you. What we're doing today is a lot of LaShot stuff. Okay, so you can hear that is actually working. And if not, there's another place to go, which I'll show you in just a moment. But when we go into my website for Monday, that link is there. We've got a link for Tuesday. Okay, that link is this, and this shows you how to do page 622, the redo problems. Goes through a lot of those. And then the video for yesterday shows a lot. Okay, not all these problems, but it just does show several of them. And then the recording for today, of course, is going to be quite helpful also. So use your resources. There's little or no class time. We just have a short day on Monday, and then you're online for a quiz on this material. Let me show you getting into my SmugMug site. On the SmugMug site, most of you know that and how to use it. So you just are going to, let's go up here to the line, owigger.smugmug.com. I don't know if you can read that on the screen, but it's owigger.smugmug.com. And when you go there, this is what you're going to see. If it comes up, there we go, good. So you're going to go down from my home page at the top where you see a picture of me and my wife and the building that I go to church in. And down here, a little bit further down, you'll see the chemistry thing, which is a picture of the thermite reaction, which is, of course, a very hot reaction. When you go in there, you're going to see basically two sections. You've got folders up here where you have labs and demonstrations. Down here, the galleries, I've been putting videos up on this site for chapter 10, 11, and 18. And so when you go into chapter 18, you'll see the videos that I've done now for chapter 18. And I will go back and find others that I've done for this chapter so that you can actually see everything that has to do with 18 that I've done this year. So that should be helpful to you. Okay, number 66 was in the homework last night. A lot of people did not do that because they didn't understand it, and I'll show you why in just a minute. But we've got here a series of concentrations that are given. Okay, we got the N2 concentration for this reaction. We got the O2 concentration, and we also got the K equilibrium. What was the 0.0500? So just had to clean up a couple of things. This molarity for the nitrogen could be written either way. Okay, you can see this little sign over here that I just moved. These guys are both the same thing. Moles per liter. And this is for N2. And the brackets mean that it is a concentration. Okay. So we've got the O2 here. I'm only going to write that one way. And then we have the actual value of the equilibrium constant. So first job is to make an equilibrium expression. But before we do that, let's go ahead and take that afterwards. Let's write the expression. Here we are. Okay, products are on top. And let's fix this little guy up. That wasn't a very good fix, but you got the idea. A little bit over a little. There we are. That's better. Okay, so a concentration of NO over the concentration of N2 and O2. Now notice something here. This 2 means you got a coefficient or an exponent. The coefficient becomes an exponent in the equilibrium expression. Okay? Now you got to find some way to get this to work for you, because we are looking for the NO. NO concentration is up here. Now I'm going to show you this general thing for working with numbers that are equalities, or inequalities there. So, oops, come on, can I get this to separate? I hope. R, there we go. I think I got them. Yeah, I got them. So, watch what you can do. This is fun. What do you normally do when you have to do something like that? Let's put it back. To make that happen, what do you do? You can cross multiply, that will work, but I'm talking about just making this back and forth thing work. You would have to take and multiply D over 1 on this side, and you'd have to multiply 1 over A on this side, right? And that's what you will wind up with. This. Pretty slick, huh? You can take anything that's crisscrossed and you can pull it across and make it go the other way. So let's get rid of this stuff and look at how that could apply to here. If I do this, guess what I can do? Forget the over 1, and now I have just solved for my unknown. This is the guy that I don't know. Let's get this little dude together. And down we go here. Now we're ready to solve. So we take our concentrations from up here, the N2 and the O2, and the K equilibrium. Plug them in, and we're done. Except that we have to take the square root when we finish. Okay, so what would that look like? So a little manipulation, and you'll have to watch this probably over and over again to really get it. But what I did is I adjusted the K equilibrium, and I'll show you where it started out. So I cleaned everything up a little bit, and we'll finish this guy off. Basically, that's the K equilibrium expression, and we're putting those numbers in. So now we're going to go down here and look at what that looks like. And basically what I've done is I've taken these guys and brought them over here. And how do you do that? You simply multiply both sides by these guys, the guys on the bottom. So what would that look like? In which case you can do this. And as we go down just a little bit further, you're now going to see this down here. And now that we have this expression, we can plug in the numbers. And these are the numbers that we get originally from the book. Next, we go down and we'll see that these guys multiplied together in your calculator, you'll get 3.89 times 10 to the minus 8. But now we have to take the square root, because that's not the value of nitrogen monoxide concentration. It's the value of nitrogen monoxide concentration squared. So we just take the square root of both sides. There we go. Let's get as much of that up there in the same screen as we can. And I'll tell you right now, all you got to do is get rid of the square root, and when you square root something like this, and you're good to go on the nitrogen monoxide concentration. Over here, you'll make your life considerably easier if you factor your square root thing and don't try to square root this in your calculator. So if you do that, it's very simple to see that the square root of this rounds to an even number 2, and the square root of 10 to the minus 8 is just 10 to the minus 4 times 10 to the minus 4. And so that's how you come out with the correct answer. And I hope you find that this helped.